Today we'll be discussing scatter plots and equations of lines. So example 1 deals with a trend line. So what you do is you need to make a scatter plot of the data below in the table. This one's talking about length and the wingspan of hawks. Second, you need to draw a trend line, and then you need to write its equation. Then you're going to use the equation to predict the wingspan of a hawk that is 28 inches long. So my length in inches is going to be my x. My y is going to be the wingspan in inches. And then I have to look over here to figure out the scale and what will work. Well, my smallest number here is 16, and I have to go up to the largest number of 24. There's not 24 across here, but I know I can skip, so I'm going to put that so that everybody will notice that I skipped to 16, and then I can go by ones and it will fit. So 16, 17, 18, 19, 20, and I'm just going to number every other one so it's easier to read. 21, 22, 23, 24. 24 is as high as I needed to go. Then, if I look at my y-axis, my smallest number here is 31, and my highest number, I believe, is 46. So again, I don't have to start till 31. So again, I'm going to put this that says there's a break in the graph so that I can start at 31. That's hard to read, I'm sorry. And then again, I'm going to skip, and I'm only going to number every other one, but I'm only going to go by one. So 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, and I almost made it. I'm just going to go ahead and add another one there. Let me try to use a straight line here. And I'm just off by one, so we're just going to add it in there. That would be my 46. Except for it jumps clear up there when I do it, so I need to drag it down approximately right there. Okay, so then we go ahead and we plot these points. So 21 goes to 36. 21 goes to 41. 18 goes to 38. 24 goes to 46. 16 is 31. 19 goes to 39. 17 goes to 35. And 19 also goes to 46. So my scatter plot looks similar to that. A trend line then is a line on the scatter plot drawn near the point. It's used to show the correlation. So you will need a straight edge. Basically, you want to show where the majority of the points are. So if I look here, it might not necessarily go through any of them. It can sometimes. It looks like if I have a trend line, it generally looks like most of the points are kind of following this path, let's say right in there. Okay, so it's showing me a positive correlation because it's going up. So as the length goes up, the wingspan is going up, which makes sense if you think about it. Generally, that's how it would work. Okay, in order to write its equation, you are going to have to estimate 2 points on that graph. So if I look here, if I'm looking for 2 points that are close to this graph, this one looks like it might be on there. 22, 42. And then a second point on here would be 23, 41, 42, 43. All of us might have a slightly different trend line. It all should be pointing upward, and then somewhat of it same position, but it might be a little bit different. So our equation, depending on our trend line, might change. So my equation is going to look like this. I'm going to have, and it doesn't say what format you need to write it in, so I'm going to write it in point slope form because I have a point and now I'm going to get its slope. You can get its slope by using the 2 points we chose, or you can get it by looking at the graph here. So I chose 22, 42, and 23, 43. So I went up 1 over 1. So according to that, my slope is 1. And then I'm going to pick one of the points. So I'm just going to pick my first point. So all of our equations might look very different. So we have y minus 42 is equal to my slope of 1, x minus 22. So there's the equation of my line. And the next thing it said to do was use the equation to predict the wingspan of a hawk that is 28 inches long. Well, my length was in my x, so I'm going to sub in 28 inches long for my x. So I have y minus 42 equals 1 times 28 minus 22. So if I go ahead and simplify, I have y minus 42 equals 28 minus 22 is 6 times 1 is 6. I'm going to add 42 to that, and I have y equals 48. So my prediction would be that the wingspan would be approximately 48 inches long. I would double check to make sure you do every part of the story problem. I made a scatter plot, I drew a trend line, I wrote the equation, and then I made the prediction. So I have completed all the parts of this problem. Okay, our definitions here for a line of best fit is the trend line that shows the relationship between two sets of data most accurately. And then our correlation coefficient of R tells you how closely the equation models the data. So it's going to tell you how close that equation really is to the data set. So again, the trend line that best shows it is the line of best fit, which we are always trying to draw when we do a trend line. And the correlation coefficient R tells you how closely the equation models the data. You will get a number between -1 and 1. The closer it is to 0, 0 means there's no correlation. So your equation does not mean anything. It wouldn't have anything to do with it. So that is bad. You want it to either be closer to 1, which means it's a positive correlation, or closer to -1, which would mean it's a strong negative correlation. So example number 2 is the line of best fit. So it says, using a graphing calculator, find the equation of the line of best fit for the data below. What is the correlation coefficient to 3 decimal places? Well, before you do this, I want you to do the following, because some of our calculators are not set up currently to find this. So what I need you to do is do the following. I need you to hit second and then 0. Once you are there, you need to scroll down to diagnostics on and press enter. Once on the screen, press enter again, and the screen then should say done. That means you have turned the diagnostics on, so the following part of this then will work. If you don't do this diagnostics on and it's not turned on your calculator, the next part is not going to work. So what we're going to do is we're going to do that diagnostics test. So go ahead and do that, because otherwise it's not going to work. So I'm going to hit second 0. I'm going to scroll down to diagnostics on. I'm going to hit enter and then enter again so it says done. And now I can do the following. It says use the edit feature of the stat screen on your graphing calculator. So you are going to go to stat and then you're going to hit enter. Stat is next to the arrow keys and then you're going to hit enter because edit is 1. It says enter 93 for 1993 and 100 for 2000. So for 93 I enter 93 in the graphing calculator, 94, 95, 96, 97, 98, 99, and 100 for 2000. So basically it's making a list under L1. Then you're going to go and enter in L2 the list that corresponds with it. So for 93 I have 340. Enter. 369. Enter. 402. Enter. 430. 457. 489. 527 and 574. If you are watching this at home, you probably do not have a graphing calculator with you, so you will need to attempt this when you get back in the classroom to make sure you understand how to enter it. Once you have both sets entered, you're going to use the calculator feature in the stat screen. So once again, you hit the stat button, you arrow over to the calculate button, and then once you do that, so you hit the stat and then you go to calculate, you are going to enter the number 4 in order to get the equation. So number 4 and then enter. And then it gives us kind of a weird looking screen. It says the following. It says line regular y equals ax plus b. So instead of m, they're using an a for whatever reason. It says a equals, in my case it enters 32.333. The 3's are repeating. B is negative 2671.6 repeating. It gives me an R2 number. I'm not going to write that down because we aren't concerned with that. And then my R number is 0.9964509, and it keeps going. Okay, so the first thing it asked me to do is find the equation of the line of best fit. Okay, my equation is going to be in the form of y equals mx plus b. M is given to me as a, so my m here is 32.3 repeating, which is 1/3. X plus b is given to me as, and that's a negative, so I'm going to erase that. It's a negative 2,671 2/3. And that's my first part, is to give the equation of the line. So I have that done. The second part says what is a correlation coefficient to 3 decimal places? That's my R here. So to 3 decimal places, that's 0.996. Basically, it means it has a very strong positive correlation because this number is close to 1. So there's your equation, there's your R. Go ahead and complete the quick checks for this section, and then you can look at your schedule to see your assignment.